Hey, we're back. And we're designing a language. Really cool. Or at least I'm having fun. Shout and chat if you're having fun or something. So the first kind of 20 minutes we spoke about the expectations for the language and how I got to this point of wanting to make a language and what I consider important about it. And we got a list of important things which should guide questions that we have about language constructs. So I thought it would be a good chance to start, a good time to start talking about actual syntax of the language. Now, at this point, it's kind of interesting to talk about whether there should be a white space, a significant white space language like Python or CoffeeScript or less, or whether it should be something with delimiters like Ruby or Visual Basic or C# or Java or JavaScript or PHP. And I see good arguments for doing white space significant languages. If tabs are super important to the language, like they are for CoffeeScript, like they are for Python, then what tends to happen is that everyone's code looks the same, which is good. It's good that everyone's code looks the same, in as much as you don't get confused when you go from one person's code to another person's code, and you don't struggle about code style. It's not as obvious or problematic, at least, where someone puts their braces, because there are no braces, because tabs mean context. So that's a good thing. But having said that, this doesn't always copy well. You know, if you're trying to send code if you're trying to get code from Stack Overflow, if you're trying to send it an email or instant message, if you're trying to format it, changing tabs, changing from spaces to tabs, changing the level of indentation of spaces or the level of indentation of tabs, it can cause unexpected errors. Okay? It's also, I feel, more difficult to make a parser where white space is significant. Not phenomenally more difficult, but more difficult. And so I think it would be a good idea not to have significant white space, to have delimiters. The question is, are we going to do curly braces? Are we going to do if something end if or end, as in the case of Ruby? And Ruby doesn't even have the brackets, so it's if something new line, end. Do we do the delimiters like that? Because I write a lot of PHP and because I write a significant amount of JavaScript, I kind of like curly braces. But to be honest, I'm kind of not sold. I mean, I think doing delimiters, like having end, just separated by the level of indentation, is perhaps not as clear versus curly brace, as what the proponents of this would have you believe. People will argue sometimes that this, which is more standard for languages like Java or PHP or JavaScript, that this is perhaps less legible or harder to read than things like this. And I don't know that I agree with that. I don't know that it is that important. In any event, I kind of don't think we need to make a decision about this right now. Just having delimiters, I think, is enough of a decision for now. So curly braces probably, or maybe even end to denote the end of blocks. Either would be okay, but I think having delimiters is better than having significant white space. Okay. Now, what other things in languages, what things in languages confuse people? I think there are two. I think testing is actually the main. I think testing is more significant than beginners find it difficult to make mistakes. I want it to be easy, most of all, but I want testing to be a big thing. And for testing to be a big thing in object-oriented code, in any code, writing a test is as simple as writing a function, okay? But the more complex your objects get that define your system, the more difficult it is to test them. And you start bumping into problems like not having global references because it's hard to substitute them, or not creating high coupling because then you test multiple things at once when you only want to test one thing, or not injecting dependencies, that it's good to inject dependencies because if you don't, then you can't put in a mock. You have to test multiple things again. So a lot of program architecture decisions are kind of made to try and avoid it being difficult to test because of the increased complexity of things in object-oriented programming, predominantly. And one of them, I think, which is not spoken enough about but contribute a significant amount to the general mess of a system, is when you're defining something in ES6 or in PHP, you have something. When you're defining a class, you have syntax similar to this. So you have a class keyword, and then you have the name of the class, and then you have an interesting keyword, extends. And in very few languages, you can extend multiple things with some terrible side effects. In most languages that I am familiar with, you can only extend one thing. And what this does, in case you haven't programmed in a language since the 80s, is that bar class defines a set of behavior, and objects of bar class have access to properties and methods defined in bar class. And when you extend it with something else, foo class inherits those, except for the things it chooses to override. So you have a way to pass down functionality from class to class to class to class. And this can be any length, right? You can have a class hierarchy of like 60 things. And when you're inspecting this code, you have to look for something, like say you're looking for the hello world method. You go into foo class, you don't find it there. You go one level up. Is it in bar class? You don't find it there. You go one level up. Is it in whatever class? You don't find it there. And you keep traveling up until you find it, and then you can debug it. And an alternative to really deeply nested class structures is to inject stuff. So foo class, and then some kind of constructor, this is pseudocode, accepting an instance of bar class. And then this bar is $bar. And so this will assign it to a variable, and then you can, this will assign it to a variable, and then instead of calling parent methods or accessing parent properties, you call public methods and properties on that instance that you have now wrapped inside your constructor. So when you create a new foo class, you give it an instance of the bar class, and you access things that are public on the bar class. You don't use parent stuff. You don't inherit anything. Yeah, so Baigan, if I'm pronouncing that correctly, I'm sorry if I'm not, or Egan, I don't know. Yeah, Python is pretty, and the reason I think it's pretty is because it is so consistent. When you have significant white space, all your code looks like all your code, and all your buddies' code looks like all your code, because everyone just uses the same significant white space. The variations that you can have from your code to the next person's code to the next person's code are extremely limited, because most of the formatting in any source code is indentation, spacing, and where you put brackets. That's it. That's it. So, yeah. Okay, but I'll address that. I'll address that point about Python being pretty and how to get this code to be pretty as well, because I think it's partially solved. I think the problem is partially solved. Also, sorry if there's a delay. You may have asked that question like half an hour ago. Difficult to tell. Anyway, so where was I? Okay, back at this. There are two options that are generally used in order to share functionality. The one is extending in an n-dimensional class hierarchy, and the other is decorating, if you will, or composition. You compose objects from other objects. You store instances instead of extending parent classes. And I think this is a lot better. Okay, this approach I feel is a lot better because you don't create messy classes. What often tends to happen is that you have some base class that you think all your classes will inherit from. Like, let's call this is a badly designed system, right? So let's say you have a human class. And the human class, it's kind of an abstract class, right? You want all the properties of a human to be in this class. You know, so you get all the mammalian properties, you get all the bipedal properties, you have behavior for eating and drinking and sleeping and all the stuff. And then you have a few instances, like you have a Chris instance, and that extends from human. And then you get to a really interesting problem where you have to do a monkey instance, right? You have a pet monkey and you want to define it. And actually, the chimp is very, very, very similar to people, except in like slight appearance and slight behavior. And it's more convenient to extend the human class than it is to create a new set of class that duplicates a whole lot of stuff. This is the curse of don't repeat yourself. So don't repeat yourself is a mantra that programmers often fling around to say, don't make two pieces of code that do exactly the same thing. Put them in some abstract container and share that abstract container. And what tends to happen is that it's often more convenient to share the wrong base and to ignore the properties that you don't find convenient. So you have your pet chimp and it extends human because so many of the things in the human class work with it. But then you have things like get middle name, and chimps don't have middle names. What is this? Reginald Monkeyface Edison or whatever. Chimps don't have middle names. So you ignore that method. You ignore the properties associated with that because you don't want all of the human class, but you don't want to have to repeat stuff because dry is good and repeating code is terrible. You read on Stack Overflow. And you tend to start creating class chains where you have subclasses that have mostly what they need, but you also have a little bit of baggage from all the way up. And you don't need all that baggage and you don't want all that baggage, but it's more convenient that way, right? Versus composition, where you have something like you have a Chris class and you have a monkey class, and the behavior that you share is composed of other objects. So you have a digestive system object and you have a skeletal structure object. I'm thinking of like eating and walking, but anyway, you have these bits of behavior and characterization that you can share by passing instances of them to more abstract classes like pet monkey and Chris. So I think composition is a lot better, and I think composition avoids carrying along all that baggage down the inheritance tree. Now, how would we say this in a language? Like, what would we call this thing? I think if we have classes, and I think it's a good idea to have classes, so have classes, but they can't extend each other. Wow, so have classes, and they can't extend each other. Of course, if I could spell. So what does this give us? I mean, thinking about this now, why do we want to have classes? If they can't extend each other, what's the purpose of them? Well, a class is kind of like a more complex function, right? I think we should have functions because that's like bread and butter of a programming language, and every programming language I've used has some kind of functional procedure. I think that's fair, right? You got to be able to do functional programming in a language. But a function is a very simple thing, right? And when you're designing good software, you want to have smaller functions that have less code and just more functions. And that's because the shorter a function is, the easier it is to test. And testing is a high priority in our language. So we want to have functions. But what is the purpose of classes then? Surely you could just have class properties as function arguments and the whole of the logic of a class wrapped in a single function. Well, I think functions, I mean, classes are really good for encapsulating stuff. So hiding the logic that would otherwise be plainly visible and perhaps unnecessary in a larger system. And you do that to a smaller degree inside a function, but maybe classes are a way of tracking related functions and sharing context between them, which is what you would have class properties for. So I think having classes is still valuable even if you can't inherit. But I think that we should have some kind of have inferred interfaces. Okay, so an extension of this is that I think interfaces are brilliant. If you haven't used interfaces, if you've done a lot of JavaScript programming, you may not be familiar with this concept of interfaces. An interface in PHP or in other languages where I've used things, whether they're not named interface or not. Yes, dry. So in languages that I've used interfaces in, they define them as kinds of contracts. So you have multiple classes as implementations of something. And an interface keeps all of those classes behaving in an expected way. Let me give you an example of this. I can have a mailer interface, and that mailer interface is going to have methods to set a subject, set a body, set to, set from, and send. Okay? That's the kind of behavior I expect from any kind of mailer class. But there are different kinds of transports. So sometimes I'll be using the PHP send mail function. Sometimes I'll be piping to a command line utility. Sometimes I'll be using an SMTP server. Sometimes I will be using an API to send, like with Mandrill or Mailgun or SparkPost or whatever. And in all of those cases, how I implement them is going to differ wildly, right? But I all want them to behave the same way. So there's this thing called an interface which says, implement this however you want, but you have to have these methods. They have to have expected properties, they have to return expected types, and the rest completely up to you. But if you implement a class, if you implement an interface in a class, it's got to behave in this way. And PHP does this interestingly. I don't have a major problem with how PHP does it, but I very much like how languages like Go do it even more. Because in PHP you define a class and there you say this class implements, this SMTP mailer class implements mailer. And that's part of your public API, right? You have to have methods defined as that. If the interface name changes, you change the implementation like that. It basically, it ties the class to the interface in a way that I don't think is completely healthy. Whereas, if you do something like Go's very interesting. It has this concept of interfaces, right? You can define these kinds of things. I'm not sure what all the exact terminology is with this. I just remember what I learned about the concepts of Go. And that is that you can define these things which are contracts, right? You can say, and a mailer has these methods. But when you make a class, when you make an implementation, you don't say SMTP mailer extend or implements mailer. You just define the mailer. And you can determine whether the implementation implements that interface. And if it does, you use it like it does. So it's like saying you create your whole framework and it has a mailer interface, and whatever instance you give it, that's fine. But if the mailer instance that you give it doesn't implement the interface, you error. But you don't have to say on the implementation implements this interface. In fact, you can implement multiple interfaces implicitly, and that's kind of cool. So I think inferred interfaces, or I think maybe implicit interface is better. So if the classes have methods matching the signature of the interface, we want to say, okay, this actually implements this interface. And maybe we want to match this up at compile time. So we want to see, okay, this class does match this interface. So when you render this to PHP, say class whatever implements interface. And so in PHP, the code will show that it implements that. But you can you don't have to define that when you've defined the classes in this language. I think that's really cool. Now, if we don't have extension and we have interfaces, it's gonna it's going to be a bit of a pain because sometimes we'll want to repeat code. And I think PHP traits are an interesting way around this. So traits in PHP, if you're unfamiliar, are they're kind of a helper for interfaces. They're a compiler-assisted copy and paste. So you can say, you can define a trait with some methods and some properties, and then you can have a whole bunch of classes, and you can say, each of these classes use this trait. And so at runtime, or compile time at least, it will copy the code from the trait into the class. And so it will be as if the class has those methods and properties. And I think that's okay. But I want kind of limited traits. And I want these traits to, let's see. I want these traits to only be able to define methods. So there's no defining properties in these traits because I want them to be exactly that, copy and paste. Okay. How do we get around sharing properties? We just define them. We just define them. I think properties are an implementation detail, right? Traits are behavioral and sharing behavior is okay. Traits can expect methods. That's good. So we can define abstract methods just like in PHP. So let me give you an example of a trait. Say I have pet monkey and I have Chris as like a human. A trait might be eats. And the eats method might use other methods implicit to the class that it's applied to or used in, but it doesn't have to define those. So maybe the trait uses a method like get preferred food. And so pet monkey will have a method that returns the monkey's preferred food, and the Chris class will have a method that returns Chris's preferred food, which is marshmallow fluff or chocolate or fudge or lots of sweet things, apparently. Apparently I like sweet things. That's all I'm good for. Anyway, the traits can define abstract methods that they require, just like you can do with PHP. So in a trait in PHP, you can say public abstract function, whatever, and the trait will require that from a class it's applied to. I want to keep that same thing. All I want to remove from the traits as they work in PHP is the ability to define properties. So you can make new classes, you can't extend other classes. Those will have implicit interfaces that they adhere to. And you can use traits. I'm not sure about the naming. Some languages or platforms have mix-in. Some platforms like PHP have traits. To be able to share methods. Do I want to limit the amount of methods per trait? I don't know. I don't know if I want to. Objective-C has a similar idea to what I'm trying to get with traits. Objective-C, is it called category? It's been so long since I've written Objective-C, I don't remember. Customizing existing classes. So this is monkey patching, to be sure. Right. Okay. Okay, so Objective-C has this monkey patching idea, but it's kind of what I want to go for with these traits. And maybe I want to limit traits to a single method. Maybe that's what I want to do. Is that what I want to do? That's what I want to do. I totally want to do that. Okay. Limit to single method. Now, I think there's a good reason for this. Interfaces can define collections of methods that make sense for an implementation of something. Traits can define a single method, but you can use multiple traits per class. Multiple traits. Wow, my spelling. Per class. So you can define multiple entities that have a single method that can be reused in multiple classes, and you can expect abstract methods just like in PHP. Multiple. Okay, I think this is good. Now, we haven't yet touched on, we've danced around the idea of testing making this easier, and I do want to focus more on that, but I just want to take another quick break. So I'm going to go for 2 minutes, listen to some music, and I'll see you right now.